Okay. Okay, total learning hours, it is 120. There is including the time that we spend during the class, and also the time that you are going to spend on your own doing homework, revision, etc. Okay, so the total cumulative is 120. There is a special way on how to calculate this one. Okay, prerequisite for this particular subjects, of course, is nil, means nothing. Okay, and the synopsis is like this one. You can see it. Okay, the course cover basic concepts, theories, and methods to solve dynamic problem with emphasis on the planar kinematics and kinematics of particle and rigid bodies. Okay, and the learning outcome for this particular course is you should be able to correlate concept relating to rigid body motion, force, moment, velocity, and acceleration. Okay, then the second one, solve problems involving rigid body motion, and the last one, the third, explain the free body diagram using Newton law of motion. Okay, and this is all the learning outcome that I will evaluate you guys on. Okay. Okay, this is a list of topics that we are going to cover. That we start with introduction. Of course, this week we have this session. I think about 1 hour. And the second one, next week we will start with the kinematics of particle. For rectilinear means something that moving in a straight line. And then on the third week, we are looking into the kinematics of particle, curvilinear motion, which is, for example, a car traveling to a corner, okay? Seleko in Malay, normally we call it, right? So, curvilinear motion. And then we look into the kinematics of particle, kinetics of particle, normal and tangent. I suppose some of you might notice that sometimes the word is kinematics, sometimes the word here is kinetics. Okay, there are difference. There is a big difference between these two. I think I will explain it to you later, not now. Okay, just focus on the simple stuff, basic stuff. Okay, kinetics of particle, normal and tangent. Okay, I think you can recall what you have learned when you took physics subjects, where you have for any forces, you can resolve. I mean the vector. You can resolve that particular vector into the normal component and the tangential component, if you can recall. And then planar kinematics of a rigid body. Okay, and then for the rigid bodies, number 6, 7, 8, until number 9, okay, we have the moment of inertia, equation of motion, work and energy, and then we have the last one, impulse and momentum. This is how we solve that particular rigid bodies problem. You can use either of these techniques. Actually, three techniques. First one is using the what you call that, second law of Newton's second law, F equal to ma, and then you can also use the work and energy methods, and lastly using the impulse and momentum. Suppose you want to resolve something that is impact, relating to impact. Okay, and then last part is a little bit of introduction to the mechanical vibration. Okay, it is hours that we are going to spend throughout our 14 weeks. Okay. There is more detail. So for the introduction, of course, the introduction to dynamics, rectilinear motion next week. Following week is the kinematic of particle, rectangular coordinates, normal and tangential coordinates, polar coordinates, relative and constrained motion. And it is one of the example of something to do with kinematics. With dynamics. Okay, and we will also look into the motion of, for example, an aircraft. There is, as you know, the aircraft will take off and turn and descend and doing many stuff. So there is a lot of motion involved. So we can analyze that particular problems. And then moving on, number 5 here, planar kinematics of a rigid body. We look into the rotation, absolute motion, relative velocity, instantaneous center of zero gravity. There is special methods that we are going to use to solve problems. For example, on this one on the right here. Okay, relative acceleration, motion relative to rotating axis, etc. And number 6, planar kinetics of rigid body using basically the problem is almost the same. The only differences is what's that? Okay, the only differences is a moment of we have the using the moment of inertia method. Okay, speaking of inertia, if you can recall, last time you heard about the mass moment of inertia, and the other one is a area moment of inertia. Okay, so there is a different. Okay, then plane kinetics of rigid body. Okay, we will look into the equation. EQ stand for equation of motion for plane kinetics, and then equation of motion for translation, equation of motion for rotational about fixed axis, and then equation of motion for general plane motion. Okay. For example, down here we have a ball that is rolling, okay, rolling from left to the right. Then in this case, what happened is the kinetic energy will involve. Okay. There are two parts of it. One is the, because this ball will move from one place, let's say point A to point B, therefore we have this component, the first term, and then we can see that the ball is actually rotating, okay? Then we have this particular term. The detail we will learn later, no worries. Okay, and then we will use work and energy methods because some problem it is quite complex in the sense that, for example, like this, the cyclist is going up to these particular hills and then going down, and sometimes it's go up and down for a few times because there is a lot of hills, small one, the big one. So we want to evaluate it all together. So we may need to use this method, work and energy method. Okay. And then impulse and momentum. As I said earlier, that this particular method is suitable when you have a problems that involve something with impact. Okay, like this one. there is a car, uh, in, uh, there is a car accident where this one car hit this yellow car, okay? And the problem that we are going to look at is the linear momentum, angular momentum, interconnected rigid bodies, conservation of momentum, and impact of rigid bodies like this one. Okay, last part is on the mechanical vibration. Okay, we have a free vibration of single degree of freedom. And then we will look into this undamped free vibration, damped free vibration, and then the categories of damped vibration, and also the logarithmic decrement. Okay, as you might notice, the use of this particular, we call it fork, bicycle fork at the front here, to absorb some undulation or some impact that going through this tire, so that the impact will not be that much when it reaches to your hands on your handlebar, on the bicycle handlebar. Similarly, for the motorbike here, okay, where we also have this particular shock absorber, and this one we call it the monoshock, because mono stand for one. Okay, only one shock absorber at the back to absorb some amount of vibration. Similarly, for drones, okay, drones, aircraft, there are a lot of things out there that needs some uh, some solution, so that the problem related to vibration on that particular mechanism can be minimized. Okay, on this particular example, the drone itself, as the drone is flying, the motor will spin at very high speed, and not all, yeah, we have actually, for the drones like this one, we have 4 motors, electric motors, and if it is flying out there, then you might notice that the drone is subjected to the wind, okay, and it will automatically want to overcome that particular wind. Then during that particular process, the drone will have some motion, and will affect this gimbal down here for the camera, so that to minimize that motion, then this particular rubbery parts here will be installed, so that some vibration due to the motion, unwanted motion, high frequency motion actually, so that it can be absorbed. Okay. Okay. This is the books that you can use. Normally, I'm referring to Hibbeler, and the second one by Beer, and the third is from Merriam. Okay. I will use 3 of these. Okay. Okay, some of you might also want to know about the how the assessment or your marks, okay, will be counted or evaluated. Okay, For these particular courses, we have a final exams that will carry 40% of your total marks. Then for the continuous assessment, during our 14 weeks, starting from this week, that will accounted for 60%. Okay. Normally, we will have 2 tests. Okay. The marks, the total marks is 30, is either 20 plus 10, 10 plus 20, or equally divided, like 15 for test 1 and another 15% for test 2. Okay, that is the things. Yeah. I will do it based on your uh, current progress. Okay. Okay, now for this particular test, I will do the test 1 either during week 6 or week 7. Okay. And for test 2, it will be sometimes in week 9 or week 10. Okay. Or even week 11, depends. Depend on your performance. Okay, and then we have up to 5 quiz. I put 5 means it will not go more than 5. Okay, 5 is the maximum number of quizzes. And the same thing goes for the assignment. The maximum is 5. It can be 2, 3, 4, 5, but it cannot be 6. Okay, got what I mean, right? I put the maximum number, so easier for you to keep track on it. And the percentage of each quizzes, the marks for the quizzes and assignments, each of them might differ from one to another. For example, quiz 1, the total mark is 2%. Quiz number 2, the mark is only 1%. So the mark will vary depending on the level of that particular quizzes. The same thing for the assignment. Okay. And then we also have a project. Okay. Project that is related to our subjects, dynamics. I will brief you on how to do this particular project later. Probably right after your first test. Okay. I will brief you on this one. Then the presentation, of course, the presentation is related to the project. So you need to do a presentation. Last time I asked all of the students to record their presentation. So it is a video presentation. Then afterwards, after I have go through each of the video, I will arrange one particular online session so that I can give feedback. Okay, somebody can put hi doctor up there. I don't know. Okay, and for further explanation, what is this for this particular example? Sorry, for this particular subjects. Okay, you can see that with the knowledge of dynamics, you can actually translate that into this set of pulley system. Okay, why we need a pulley system? Pulley system is one of the what we call mechanical advantage that you can reduce or half or even make it 10% of the total effort to pull this bicycle up. let's say without this, let's say the bicycle is weight like 20 kg, the total weight of the bicycle is 20 kg. With a pulley system, you might need like 10 kg of forces. Okay, of course 10 kg multiplied by the gravity lah. Okay, so that's why we have this mechanical system. Similarly, for these robotic arms, you can actually design the whole parts here, like the gear, how big the gear should be, how long this particular arm should be, because you are going to put like servos. Do you know the servos? Anyway, servos is similar to the electric motors. It is actually electric motors actually inside this particular servos. It is the servos. And the servos will give some rotating, what do you call that? Give some rotation so that these particular parts will rotate, move, okay, in the direction that you wanted it to be. Okay, anyway, and for an aircraft, if you notice, if you sit somewhere near this this window here, you can see that this particular parts on at the back of the wing, okay, we call it the flap, and this particular flap will move, okay, will go a little bit behind, and then up to some point it will retract, go inside this particular wing. So that sort of stuff normally you can see during takeoff and landing. Okay, to design something like this, you need the knowledge of dynamics. Okay, how fast these particular parts need to retract. Okay, how much forces is needed to perform that particular motion, so on and so forth. Okay, and this one is for satellites. Okay, satellites, you also need a knowledge of dynamics to perform this mission. For example, this is your satellites. Okay, right after it's being being deployed or disengaged, okay, up there in the space, then it will deploy its own so-called solar panel so that it can power up all the system on board, the onboard system. So the dynamics of this particular motion or the kinematics, you need to understand it. Okay, for the aircraft, for the landing gear, just now I'm talking about the wings. Now we are looking into the landing gear, where when the aircraft take off, okay, this one is take off. Take off at some point, certain altitude, the landing gear, we call it landing gear, this particular wheels system of an aircraft, we call it a landing gear, will be stored in the under the belly of this particular aircraft. Okay, we call it undercarriage. Okay, okay, and then for example, you want to go to this theme park. Okay, you can actually do a little bit of analysis if you want. Okay, do a little bit of analysis so that you can relate what you have been learning in class, that you can apply the energy methods so that you can know how fast this particular roller coaster can go. Okay, for example, when it reaches up here, what is the speed that is needed so that it can go up to this point? Okay, okay. Something related to COVID-19, where there are a lot of effort being done right now. For example, there is a group from UK. I forgot to put the details down here. From UK, what happened is they designed this a module for this manual what do you call that? I bought one actually to design this particular system, but I didn't complete the project. What do you call this one? There is a specific name actually. The idea is to supply air to the patient who have a problem to breathe. Okay, I forgot the correct name of this one. Okay. Okay. If you notice, this is a crane. This is a crane. If you notice, for the crane, there are a set of pulley system. Okay, this set of pulley system. Later on, we are going to learn on how to play around with this set of pulley system so that we can design something that is useful, that perhaps, for example, you want to lift up this 10 kg of weight, and 10 kg of weight you can translate to about 100 Newton, and then instead of pulling this at 100 Newton, you can just use 25 Newtons, okay, due to the design of this particular system. Okay, it is not difficult. I will share with you later on how to do it. Okay, and that's all for the introductory for the dynamics. I hope it is something that is useful for you. Okay. So if you have any question, further question, you can put it in the WhatsApp group so that everybody can learn or can know what you are thinking, and I can reply in that WhatsApp group. Okay, no problem. But if you have any question right now, you can unmute and then you can ask question.
Doctor.
Yes.
For the slide, when you are gonna upload it in Putrablast?
Okay, I will upload right after this session. Actually, I tried to upload this morning, but the Putrablast is not working, I'm supposed. So just now I only managed to upload my picture on the Putrablast, but not the slides yet. I will do it today, no problem.
All right. Thank you, Doctor. Thank you.
Any other question? Yeah, Pika. Can see you unmute.
Our lecture is going to we gonna have 3 hours straight, or like we're gonna pecah-pecahkan?
Pecah-pecah kan?
Like
Okay,
1
split.
hour.
Okay, let me explain to you. Okay, this is not my first time doing the online. Even last semester we have this session. Okay, the way I did it is I did many ways actually. The most effective ways that I can see is that um, I will upload several short videos on YouTube. Okay, on YouTube, and then I will share with you the link in the WhatsApp group, and also I will put the link as well in the Putra Blast. Okay, and then I will allow you to have a look on that particular short videos. Short videos is actually a lecture, short lecture like no more than 15 minutes each of it, like 10 minutes. It's around 10 minutes. A multiple, so more than one. For example, like normally I will explain the theory using examples. That is much more easier for you to understand it. But of course, I will also have another short video to explain on the theory part of it. Okay, and let's say I will have like 4 videos or 5 short videos, and then I will upload in the YouTube. I will give you the link. Let's say I will give it to you on Monday, and then our class is on Thursday, like today. Okay, on Thursday. So Monday to Thursday, you have like 2 to 3 days to watch these particular videos. So during that time, you can at your own free time, you can watch these sets of videos. Okay, anytime that's suitable for you. Then during the class, we can just focus on things that you need further explanation. Okay, I think that will be more it will be more focused. Okay, we are not going to waste time, and then the session like on each Thursday, instead of 2 to 5, we can shorten it. Okay, probably just 1 hour or 1 hour and a half, depends, because I already upload in the YouTube. You can watch it, and we have WhatsApp. Even during the WhatsApp, you can ask question. If the question is straightforward, I can answer during the WhatsApp, using the WhatsApp. If the question is a bit difficult, so we can discuss during the class. That's how I did lah. What do you think? Is it okay?
Yeah, it's okay, Doctor.
Okay, thank you.
Sorry for bothering, Doctor, but I have one more question, please.
Yes.
For the attendance, is it in Putra Blast?
Yeah, I already put in the Putra Blast. Can you
Because I believe that I'm now in Putra Blast and there is nothing.
Nothing. Okay.
I don't know.
Anyway,
Is it like
yeah,
my
yeah.
issues or?
Because during when I put it in the Putra Blast, the system is freeze.
Some issues.
It's
Oh,
stuck. So I don't know what's happening. But anyway, I can see your attendance from this list of participants in the Zoom. So no worries. So your
okay.
attendance is here right with me right now.
All right. Got it. Thank you, Doctor.
Yeah. Any other question? if no more question, I will end this particular session. And okay, every session that we have, for example, right now, I will share in the YouTube. Because this is recorded, I will share in the YouTube. You can watch it. Give me like a few hours lah, because I need to do some editing to the videos. Okay. So hopefully tonight you can have a look again to this particular session videos on YouTube. I will share in the WhatsApp group. Okay. Thank you. Okay. Bye-bye.
All right. Thank you, Doctor.
Yeah.
Stay healthy and stay safe.
Yeah.
Bye.